Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fakrul Hadi bin Nuraini, and my supervisor is Mr. Muhalim bin Muhammad Amin, and I will be presenting about my final year project 1 with project title Enhancement of IoT-Based Home Security System. I will present my project according to the outlets given, which are introduction, problem background, project aim, literature reviews, methodology, software and hardware requirement, initial finding, PSM2 planning, and conclusion. So, for introduction, nowadays, urban population that lives in the residential neighborhood can connect to each other easily within the area. Most residential neighborhood planner primarily evaluates the housing demand without taking into account about the residents' demands and opinions on about their home security. So, some of the urban population does not give any attention to their house security, and most of the houses only use a padlock to prevent an intruder entering the house. So, if a home does not have a security system, tragedies such as a burglary will not only cause people to lose their belongings, but also put their lives in jeopardy. This is why an implementation of security systems in the house is crucial. So, to achieve this goal, IoT is needed to link all of the security devices into one centralized access control to each the user to control the home security system. And then, moving on to the problem background, some of the common home security problems that homeowner had is their security products will work separately, thus will be resulting in decentralized access control. So, this is a common issue for people who have purchased security products from various firms. Some of it were DIY products. So, in order to resolve this problem, is to ensure all of the security components need to be connected together into a centralized access control. So, many people who have home security cameras with sensors mounted around their home can encounter false alarms, and it is usually sound when pets such as dogs, cats or birds move past the sensor. This may be due to the overly sensitive sensors, improper installation, or manufacturing flaws. So, in order to resolve this problem is to have a double layer sensors. So, double layer sensors is used to detect the intruder effectively. It consists of two sensors, which are passive infrared motion sensor and ultrasonic sensor. Moreover, the current home security system also does not have an extended action that will allow the user to contact the police easier if the intruder has been detected at the house premises. Most of the home security systems are complete with sensors, but the homeowner needs to make an emergency call manually if the intruder has been detected. So, for the solution, the system will set up an alert message to the police and make confirmation to the user if the intruder has been detected at the house premises. So, going for the project aim, the aim of the project is to design and develop a home security system that can be monitored easily by the user using IoT implementation. The project objectives, the system to study IoT technology for design and development of this project. Second one is to design and develop the security system in the house into a single access control, and to test and evaluate the effectiveness of the proposed home security system. Then the project scope will be the system will signal and input value of the sensor, which are PIR motion sensor and ultrasonic sensor, and it will be stored in the favorite server database. Second one is the system will be tested using a real devices installation. The system will be accessed using mobile application, which is the Blink application. And lastly, the system will enable to detect the presence of the intruder by using the AA sensors, which are PIR motion sensor and ultrasonic sensor. So, for the literature review, I have studied 3 current existing systems that can be a reference for my project. For the system 1 is with title Design and Development of Home Security Systems based on IoT via Favorite platform. This project uses microcontroller, which is Espresso Lite V2.0. The sensor that they use is passive PIR sensor and infrared sensor to detect the motion of an intruder. The system also has a friendly user application interface by using Blink application. The Favorite platform will act as a server to receive data sent from the microcontroller, and the display will show the output for its conditions, and the data that sent to the Favorite server. So for the system 2 is titled IoT-Based Smart Security and Home Automation System. This system does not use a mobile application or user interface, but instead use digits from the phone's keypad. This system does not need to have a records of connections enabled in the consumers on the user cell phone, because the machine runs best with the launchpad that link to Wi-Fi at domestic or office. Then the captured picture of the guest or intruder after face detection can be emailed to the user. The user also can further forward the same photograph to the police station if he wishes. So the last system is the IoT-based Smart Security and Smart Home Automation. It focuses on security system and home automation by using the IoT implementation. So the aim of this keen security and savvy home mechanization is to accomplish comfort while staying simple. So the system just need a minimal expense framework with least prerequisites to deal with both home security and home automation. The system also can be controlled from a long distance and very efficient. So for the features system comparison, system 1 only use PIR motion sensor to sense the movement of the intruder and for the data input. It also has a main panel to let the user know about the status of the system, and the database server will be used to store data from the sensor. For system 2 and system 3 are quite similar to each other because the system focuses on both home security and home automation system. System 2 only has very limited features, which is the home alarm to alert the intruder and PIR motion sensor as an input data. So meanwhile, for the system 3, it has an extra features compared to system 2. System 3 has a security camera to capture the intruder face, PIR motion sensor, air purity sensor to detect the leaking gas, humidity and temperature sensor to detect fire, and also a main panel. So the proposed system aims to improve the current home security systems. Therefore, the proposed systems will be equipped with home alarm, security camera, PIR motion sensor, ultrasonic sensor to differentiate between the human and animal that pass through the sensor by detect the distance of it. It also will be equipped with the main panel and the database server. The proposed system does not use an air purity sensor or humidity sensor because the system only focus on the home security systems only. So for the technologies, first one is Favorite platform. Is a middleware platform that is designed for any IoT and machine-to-machine project. The platform was developed to help the internet integration of the sensor and actuator data. Blink application is an internet-based platform that works with iOS and Android to control Arduino or Raspberry Pi, and it also has a digital dashboard with widgets to create a graphic interface for any project. Next one is the Arduino Uno. Is an open source project with software and hardware that are widely available. It is simple to use. It can connect to a computer through USB and communicates using the standard serial protocol. It can also be used as a standalone application or as an interface for PC or Macintosh system. For the sensor is The PIR motion sensor is to detect motion and often used to determine if a person has entered or exited the sensor's range. The FPUT sensor detects gases like carbon monoxide and carbon dioxide by measuring the absorption of infrared light. Lastly, the humidity and temperature sensor will sense, measure, and reports both moisture and the air temperature. So for the methodology, this project implements agile development model. So when creating a minimum viable product, agile is the best development model. It serves as a feedback channel for the users and clients. So as an example, by creating an MVP that could control the home system, then add more features and gradually creating intermediate items. So for the phase 1, which is the requirements phase, a literature review was carried out in order to understand the users' preferences about their home security systems. So the primary goal is to ensure that the system meets the needs of the user and solves their problem. In phase 2, which is the design phase, all of the design of the system will be made in this phase. The system requirements that has been collected in phase 1 will be used in this phase. Then by approaching these objectives and choose the best tool to get the best outcome for the design. Moving on to development phase, all of the coding parts will be completed based on the system design that has been made. And then the testing phase, this is when the actual users test the software to see if it is able to carry out the required task it was designed. And then lastly, the evaluation phase, the systems needs to get review and feedback from the user that has used the proposed system. This phase is important to patch any bugs or virus that could disrupt the operation of the system. Then for the software and hardware requirements, as we can see here, the Blink application, Arduino IDE, and Favorite Server will be used as a software for development, and for documentation, I use the Overleaf and Microsoft Excel. So for the hardware of the systems, the system use an Espresso Lite V2.0, the UC008, the alarm, which is the piezo buzzer, the camera, the camera, which is OV7670, PIR motion sensor, and also the ultrasonic sensor. And then for the system design, the system will only use one processor, which is microcontroller. This component will be linked to 5 other components, which is shown at the figure. And then this component also will provide the data for the microcontroller before it will upload to the server. The server will act as a medium for receiving data that has been processed by the microcontroller. So to transfer and receive data between the device, the server, and the application, and also Wi-Fi is required. And then for the double layer sensors, so figure 12 and figure 13 shows the top and side view of the double layer sensors terminology. The yellow zone is the radius that PIR motion sensor covered, and the red zone is the radius that ultrasonic sensor covered. The PIR motion sensor will be positioned according to the supplier preferences, and the ultrasonic sensor will be placed at the top of the door of the house, which is above 2 meters from the ground. A human movement can be detected by a PIR motion sensor when it is within 10 meters from it. So if the system only uses PIR motion sensor, it will also detect an animal or a pet that moves through the sensor. So by adding the ultrasonic sensor, it can differentiate between the animal or an intruder that moves towards the door of the user's house. So if PIR sensor senses any movement, the system will signal the ultrasonic sensor to turn on and calculate the distance between the object and the sensor. If the distance between the moving object and the ultrasonic sensor is less than 1 meter, the system has detected an intruder, and if the distance between the moving object and the ultrasonic sensor is more than 1 meter, the system does not detect an intruder but only detect the presence of pets or an animal that move through the sensor. So why the system use the AA sensors it is because the average of human height is from 1 to 1.7 meter, and the distance between the human and ultrasonic sensor will be less than 1 meter if the human is at the front door of the house. So the animals or pet that moves through the ultrasonic sensor will be outside the 1 meter radius, thus will not trigger the alarm. So for the flowchart is the system will start by connecting the blink and Wi-Fi. After that, PIR motion sensor will detect if there is any motion presence at the door of the house. So if the motion is detected, the system will turn on the ultrasonic sensor. Then if the distance is less than 1 meter, the system will turn on the camera and capture the intruder picture and turn on the alarm at the same time. So the blink application will display notification about the intruder alert to the user. The system will also send data to the favorite server, and lastly, the system will ask the user about the confirmation to contact the police. If the user has confirmed that the presence of the intruder is at the house premises, favorite server will send an alert message to the police. If not, the alert message will not be sent. So for the use case, the users of the system are referred to as the major actors. Homeowner, administrator, and police are the actors of the system. So the user is the homeowner that owns a home and will use the system. User also can register an account and log into the system. The user can control the sensor remotely even if not around home. So, and if the system has detected an intruder, the user will receive notification through the application. And for the administrator, it is the supplier who manages the server. The administrator can track the status of the house from the favorite server, and administrator can send an alert message to the police if the intruder has been detected at the user house. So the police will receive alert message from the system and will go to the crime scene if the intruder has been detected. So for there is a total of 11 use cases. These are 8 is from the user, 2 from the administrator, and 1 from the police. So the user has registered account, log in, view sensor widget, edit sensor widget, detect intruder, capture intruder picture, signal alarm, and also receive notification. So the administrator can track house status and can contact police, while the police actor can receive a call. So every use case has their own sequence and activity diagram. So this is the example of the sequence diagram for use case number 5, which is detect intruder. The sequence diagram is used to model the logic of a sophisticated procedure, function or operation, and see how objects and components interact with each other to complete a process. And this is the example of an activity diagram for use case number 5, detect intruder. Activity diagram is used to identify the candidate use case through the examination of business workflows, and also to identify pre and post conditions for use case. And then moving on to the database part, which is the entity relationship diagram of the system. So ERD is used in conjunction with a data flow diagram to display the contents of the data store. So all of the models need to relate to each other to form an entity relationship diagram. And then the system architecture. This is the system architecture diagram for this. The user will need to log in first to the Blink application to access to the system, and then the Blink application will connect to the system hardware, secure one via Wi-Fi. Then the system hardware will detect any intruder that moves towards the door of the house, and if the intruder is detected, Blink application will send the notification to the user. And then the data of the sensors and picture of intruder from secure one will be transferred to the FiberNet server via the API that can be used from the server. Then the administrator need to log in first to the FiberNet server to access the administrator functionality. And the admin also can set a rules that will instruct the system to send an alert message to the police in case of burglary happens at the user's house, and the police will receive an alert message and go to the crime scene at the user's house. So this is for the system interface, which is the Blink application, the login page, and also the create account page. And here you can see that the home page of the application, where the user can view the sensor widget in this interface. User also can turn on and off each sensor by press the button at the top of the menu. So to set the notification message, the user can press the notification button at the top left of the screen, and the alarm widget will turn from green to red if the intruder has been detected. The motion sensor gadget will move from 0 to 1 if motion has been detected, and the ultrasonic sensor gauge will also display the distance between the object from the sensor. And lastly, the camera widget will turn on if the intruder has been detected and capture the intruder picture. There is also the edit widget interface and also the notification message interface. And lastly is the FiberNet platform dashboard. This is from the administrator side. So for the PSM2 planning, in PSM2, the hardware of the system, which is secure one, will be developed and tested to the system. The coding parts will also be completed in PSM2. So all of the IoT sensors and software configurations will be integrated into a single system. The system will also be tested by the real user to give more insight to the user about how the system works and following the requirements. And lastly, evaluation from the system will be made, and the system will have an improvement for further use. So for the conclusion, the project has successfully achieved all of the objectives for PSM1. Firstly, the IoT technology that will be used to design and develop this project has been studied. The IoT technology that being used on existing home security systems and comparison about the features also has been clarified. And the project also has achieved to design and develop the security system in the house into a single access control, and Blink application will be used as a main controller and monitor each sensor using the Blink application. And lastly, all of the interfaces design has been made to give the user a better view about the system, and each of the use case also has explained about the flow of the system. That's all from me. Thank you.